Hello everyone, welcome back. So in this section, we are going to talk about other method of integration. So far, we have studied many method about integration, like various substitution, integration by part, partial fraction, you know, and those are example of analytical method. But we have computer method, which we will see in the next section. So in this section, we will be using the table of integral and integration by parts to do the sum of this integral. We have about 3 examples right here. So the first one is, let's say if you are asked, evaluate the integral dx divided by x times square root of 2x minus 9. So you can see, again, do not forget, we do not have a quotient rule on integration. So if I have this type of integration, it's requires time to solve, right? And if you do look at this, so substitution is the best way to solve this one. We just said let u square be equal to 2x minus 9 because I want to get rid of my radical again. Of course, this mean from here, this mean what? X is equal to 1/2 times u square plus 9. And if u square is 2x minus 9, then du, because du, if you find the derivative, we'll have 2u, sorry, 2u du will be equal to 2 dx, which means dividing both sides by 2, u du will be equal to dx. So if I do that, then substituting, I will see my integral of dx over x square root of 2x minus 9 x squared minus 9 will be equal to dx is u du, so u du over x, which is what? 1/2 u squared plus 9 times square root of u squared, right? So simplifying everything, I will get what? 2 du over u squared plus 9. And you can see, you can find this one in your table of integration. So that is why, again, I'm going to write this one by looking at your table of integration or your integral formula again. So this is like tangent inverse. Your A is 3 because it's u squared plus 9. So your A is 3. So it will be these two divided by 3 tangent inverse of u divided by 3 plus c. What is your u? Our u is 2x minus 9. So it will be 2 divided by 3 tangent inverse of 2x minus 9 divided by 3 plus c. But again, we can go ahead and then give me 1 second. We can go, oh, sorry, u square is that, so I have to have a square root here, sorry. That is u square. So we are substituting u, not u square. So square root. Yeah, I know something was wrong. This one. So basically, it will be square root of 2x minus 9 divided by 3. Why? Because u square is 2x minus 9. So u will be what? Square root of 2x minus 9. Okay? But again, we can add this to our integration table. You need to know anytime if you have to find the integral dx x times square root of ax minus b, your answer will always be 2 divided by square root of b, tangent inverse of ax minus square root of ax minus b divided by square root of b plus c. Of course, b has to be greater than 0. So that's exactly, we can just use substitution and then you will get exactly the same thing. I don't want to spend too much time. Let's move. You can pause the video, just substitute. You will say your a is 2, b is 9. Just substitute a, b. You will see it will give you exactly this one. So you can add this to your integration table. So now, if I have to find the integral of square root of x squared plus 6x dx, so what should come to my mind is completing the square, right? So I can have like square root of u squared minus a squared du, which I will be using ln, right? So in that case, I will just try to complete the square, x squared plus 6x. To make it a complete square, we have to add 9 and then minus 9. So this part will be x plus 3 square minus 9, right? So that means if I'm asked to find the integral of square root of x squared plus 6x dx will be the same thing as finding the integral of square root of x plus 3 square minus 9 dx. So I can use my substitution. Now I will just say let u be equal to x plus 3, right? Then du will be equal to what? Dx. So doing this substitution, I will have square root of the integral of square root of u square minus 9 du, which by looking at the table of integration, this one will be what? Equal to u divided by 2 square root of u square minus 9 divided by 2 ln absolute value of u plus square root of u square minus 9 plus c. And then you substitute the u back. If I substitute u back, my final answer will be u is what? X plus 3. So I will have x plus 3 divided by 2. Let me move this to the left a little bit because I don't think I will have too much space. So my final answer will be x plus 3 divided by 2 times square root of x plus 3 square minus 9 minus 9 divided by 2 ln of absolute value of x plus 3 plus square root of x plus 3 square minus 9 plus c, and the rest is you just have to simplify. You can leave it like this. You will not get it wrong. The simplified part is just x plus 3 square minus 9 will give you x squared plus 6x. Okay? I have no questions so far. So on the next one that I will do is evaluate the integral of dx over square root of ex plus 1 using table and computer algebra systems. So e to the power of x. Okay, so to evaluate this integral, we will do substitution. We might do more than one substitution. Like first thing, if I said let u be equal to e to the power of x, right? Then we can see du will be equal to what? E to the power of x dx. So which means, or we know u is what? E to the power of x, so we will have u here, right? So this is just like what? Du is equal to u times e to the power u times dx, right? So we are trying to substitute dx. So that means from here we will know du over u. That's what will give us dx. So by doing this substitution, we can see we will have the integral of dx over square root of e to the power of x plus 1 can be rewrite as what? Again, du over u. So we'll have a du u square root of u plus 1, right? So again, using a computer algebra system, you can evaluate this integral easily. Or you can, since the beginning, you could do that as well. So you can use some computer algebra system to solve this one. But if you want to do it by hand, again, we still need to do what? Some substitution. I want to get rid of my square root term. So I will do again another substitution to solve by hand, which I can do. So in that case, I'm going to use let v squared be equal to u plus 1, okay? Then u will be what? So this also means my u is v squared minus 1 or 1, okay? And of course, if v squared is equal to u plus 1, so that means 2v dv will be equal to du. So by doing this substitution, now the new integral that we have, which is du over u square root of u plus 1 will become what? If I do this substitution, I will get the integral of 2v dv, because that's my du, divided by u. U is what? V squared minus 1 times square root of u plus 1 is what? V squared. So square and square root will cancel out. V and V will cancel out. So it will left what? What I have is 2 divided by u squared, V squared minus 1 dV. Okay? To do this one, we have to do partial fraction. We have to write this one as two fraction. The two fraction that we'll get will be 1 divided by v minus 1 minus 1 minus 1 divided by v plus 1 dv. You can check if you make this one term to be able uh, v minus 1 times v plus 1, that's what will give me v squared minus 1. You will have v plus 1 minus v minus 1, which will give you these two. Okay, and now we can integrate this one. You can see the first one is what? ln absolute value of v minus 1 minus ln absolute value of v plus 1 plus c. And then we have to substitute back. We have to substitute back. Sorry. Oh, let me pause and try to open a new page. So we have to substitute back our u. Let me use a new color, green. So we said v is what? We know v squared is u plus 1. So that means my v is what? Square root of u plus 1. Right? Or 1 plus u is same thing. So I will have ln square root of u plus 1 minus 1 minus ln of absolute value of square root of, or the first one is u minus 1, sorry. Yes, u plus 1 plus 1 and plus c. But since the first substitution, we said u is what? E to the power of x. So we substitute e to the power of x for our u. So that's why my final answer will be ln absolute value of square root of e to the power of x plus 1 minus 1 minus ln absolute value of square root of e to the power of x plus 1 plus 1 plus c. And you know the ln property, so if you want, you can just write it as what? Ln of absolute value of square root of e to the power of x plus 1 minus 1 divided by plus c. So it's same thing. Okay. So again, uh, it depends, if your school allow you to use a computer algebra system, you can use that to solve quickly. And if it does not, most of the time, it's better to be able to use it because some integral is complex. It's too complex. Like if your school can use Mathematica or Maple or Sage Math, you can plug this one. It will give you the result you need. Okay. All right. I will see you in the next section.